as you may be aware, well, we have gone through some interesting topics, right? First, we started with R, where actually I got you exposed to some functionalities, methods, invoking libraries, and some other stuff within R, right? Which is kind of key in order to use the tool itself to start kind of enhancing and advancing in the data analysis world. And there may be kind of, let's say, saying that this approach must be something really technical, right? Now, up to this point, we know that it's not, right? That any person can use it, just learn a little bit of the logic. And the idea is, yes, to take advantage of these powerful tools in order to start getting the power of data, digest it, understand what's exactly going on, understand patterns, understand trends, and so on and so forth, and try to anticipate to future behaviors based on what the story the data is trying to tell us. Better said, what story information is trying to tell us. Right? Before we get it started, is there any question or comment so far? Maybe you have liked it, you have disliked it, you have found it useful, has been challenging. What do you think?
Useful, but very challenging.
Yeah, I agree. Again, I know it because when I started my career on this, at the beginning was really challenging because it's what is a dependent variable? What's an independent variable? How to use it? Why is it not? Why is it working? Right? Why isn't it showing anything? Guess what? It's normal. Why? Because I mean, it happens when you started using Excel, right? You use a formula at the beginning. It may not be straightforward. Once they understand it, maybe sometimes it's not accurate. So you need to start kind of improving and also making tweaks in order to make it work, right? So today, actually, we will start with a different approach. First, we'll cover some information about another algorithm, which is called logistics regression, where actually on this part is called regression. It is a classification model, right? And I'll explain why. Because if you remember, in the previous classes, we saw more about predictions about regressions, right? So in other words, we have certain behaviors so far, we have certain transactions so far, and we would like to anticipate what would be the most likely transaction that will happen in the future, right? What would be kind of the thought around that. I know that is more complex than that. However, today I'll show you another example about how to perform a regression, but using dates this time around, and which is going to be really nice because I really love working with dates, right? Yeah, madam, I'm not sure. It may be wrong with his. Oh, you know what? I think it was required to click on accept. Thank you so much. So the idea in regression is nothing but it's a transaction that we would like to anticipate how is that going to behave in the future, right? That's for when we are talking about regressions. However, in classification, actually, you know what? I'll focus more on explaining first what classification is before going through the logistic regression. So let me use this example. Actually, we have here some really nice examples. You know what? I'll use my powerful. I usually don't like using presentations. I prefer to explain it with drawings. I know that my drawing skills aren't exactly nice as you expect, but I think it's better to explain. Okay. This is gonna be interactive explanation. What it means that you'll need to tell me. You need to tell me what we can do here. So let's think of that we have a triangle here, which is going to be green.
Professor, sorry for interrupt, but yeah. Iberia is sending a message saying that she's having some troubles with the Zoom connection or with the internet connection. So I just want to advise you.
Thank you. Good to know. Appreciate it.
Thank you.
My pleasure. So we have a square. Actually, oh, well, this is not a square as far as I know. Okay, let's have a square. Let's have, it's going to be blue. We will have a yellow. What if it will, I don't know, something like this, right? And we may have a, okay, this is going to be this color. And we will have a circle, which is going to be red. And one last but not least, let me think of another shape that we can use. Maybe, you know what? This one. Why not? Why not? So this one will be blue. Okay. Okay. Now, if you take a look to these images, how can you classify them? I mean, if I ask you, classify these images based on your knowledge, how would you classify them?
It could be shapes, it could be colors.
Beautiful. So, beautiful. Yeah, exactly. You can classify them depending upon what's the target. We can classify them into different fashion, right? For instance, what if we focused on shapes? On shapes. If it were in shapes, we would have only kind of these two classified, right? Let's include another one. Let's include another triangle, maybe. Let's include a triangle here, a blue one, and let's include what else? Oh, another square, right? A new square. Let's say this one, right? Smaller. Okay, so right. So we say, oh, you know what? I really want to classify. Want to classify the by shape, right? So that's one type of classification. So what it means that if I want to classify the squares, I also can do that, right? Let me shape here, squares. Or rectangles, better said, right? Rather than squares. And we have triangles. We have triangles. Let's classify them into a different category. Right here, right? And we may have something unclassified, or maybe those can be considered outliers, right? Because those outliers go above and beyond what I currently have in my regular. Maybe this one can be included here. Nevertheless, it's quite confusing. Maybe it's something right in the middle, right? Those are kind of the things that you need to bear in mind. When something is an outlier, you might need to think, okay, something goes out of norm. But it doesn't mean that it's inaccurate. It doesn't mean that it's a problem. You need to think, need to be creative, what to do with that. So as you mentioned, Emmanuel, also can be classified based on colors, right? So if those were based on colors, the story is quite different, right? So we can have different shapes, but classified based on the color. I mean, I'm colorblind, so I'll try to do my best with this. But actually, it's one of the main challenges that I have as a as a developer, because sometimes the customer may ask, you know what, I need to color something in this fashion, and if you're colorblind, you may suffer a little bit. Believe me, it happens. So if we take into account color, actually, guess what? We could classify them all on the SPY. Those were different shapes, right? So that's exactly the idea of classifying. You need to, you know the categories. So in this case, which ones would be the categories?
Colors.
Colors. Beautiful. And what's the other category that I mentioned about?
Shape.
Shape. There you go. Beautiful. So this is the important thing to understand between supervised and unsupervised models. Supervised models, you know what are the categories. You know what are the expected, or what's the closest expected value that it is. However, unclassified models, it's something that we will take a look with clusters in the upcoming classes. You don't know the categories, so you would like to visualize what would be the best categories based on your experience, but the algorithm will help you to classify them. So that's the great power about this. So is this crystal clear about classification? Crystal clear, isn't it? But what also in your jobs, what would you classify in your business? Give me an example. What would you classify? Transactions, maybe?
Revenue.
Revenue, whether it was achieved or not, right? That's a classification. So the idea for a revenue is to achieve the goal. So either you achieve it or you did not, right? So it can be considered, it is both. It is a non-linear regression because first you want to anticipate something that it's going to happen in the future, but also it's a binary or a logistic regression because either you achieve it or not. That which is a very good thing. Beautiful. Thank you, Roberto. Someone else that you may think of, what would you classify?
Type of projects. I mean,
Type of projects. Exactly.
Water projects, energy power projects, roads, etc.
And also you can classify them by budget, right?
Yes.
One of them can be perhaps $1 million. Maybe another one is only $100 and so on and so forth. So you establish thresholds and you can create those categories based on those thresholds for projects. Also customers. You can classify your customers. How would you classify your customers?
Maybe with
By
the
region?
sorry, go ahead.
Sorry.
No,
Go ahead, Emmanuel. No, I was telling by region.
The region.
Yeah, maybe by the churn risk, like the health score, depending in which segment they are.
Exactly. And for each and one of you, the classification may be different depending upon your business. Right? This is the beautiful thing about machine learning, that you can reshape the models depending upon what it's better for your business. So for example, well, now that I have explained a classification model, actually, I will not stick that much into the theory. The only thing that I'm going to explain is one thing. So logistics regression. So how logistic regression works? The one that we're going to take a look today, it's this one. So the logistic regression I told you is pretty much what is considered, it's considered both a regression, but it helps you to identify whether something fails or succeeds, right? It's pretty much. So in other words, let me give you an example. You are taking temperature, or maybe let me rephrase that. Yeah, you're taking temperature for a specific experiment that you are doing. So if it goes, if your experiment, if the chemical reaction goes above 100 degrees, it's successful. If the chemical reaction does not achieve the 100 degrees, it's not successful. Or let's take the other example, the one that Roberto mentioned, the forecast. So you can use logistic regression to understand whether you're going to achieve it or not. Because one thing is the linear regression. One thing is the nonlinear regression, where actually it's going to let you know the trends based on what you have spent already. However, the logistics regression will let you know whether you are going to achieve the goal. So it's another model that actually it's a proof of concept, whether you are going to achieve the goal or not, right? So in other words, if you are doing linear regression or nonlinear regression to understand how is your forecast behaving, that's one thing. However, yet I suggest you to use the logistics regression, which is going to use another logic behind the scenes and would let you know that based on your records and your analysis, whether it's going to be successful or not, right? Crystal clear? It's kind of a proof of concept, kind of validate what you have forecasted in your linear regression. So good so far? Another example is, for instance, the engine in your car. The engine of your car requires certain maintenance. Every 500,000 kilometers, 5,000 kilometers, or maybe every 10,000 kilometers. It depends on the car, right? Some cars actually has an engine that lets you know, or alert that lets you know what? Your car requires that particular maintenance, right? So the logistics regression would help you to anticipate whether something requires maintenance, yes or not, without having that engine, based on historical records, and it would let you know what? Requires maintenance, and so on and so forth. So, however, let me show you other examples, but in reality, right? Using the code, not in reality. So, in other words, is if you predicted something, like another example, stock market. One thing is projecting how much is that going to be. right? So once that you have established your goal, which would be your regression, that's your goal. However, the logistics regression would prove whether based on that prediction that you made, for instance, let's say that I make the prediction for the next 6 months, right? So I performed the linear regression to anticipate how is that going to behave in 6 months. And now I know, let's say that now I'm in $50,000 and I know that I'm going to earn $75,000, right? So in 3 or 4 months, what you do, instead of performing another linear regression to see what you are doing, you perform the logistics regression to see whether you are going to achieve it or not, because that is pass or fail, right? Because the logistics regression will readapt based on historical records. Instead, you use the logistics regression to prove whether the goal is achieved or not. Crystal clear? Why am I saying that? Because, for instance, let me use my powerful skills of PowerPoint. I'm sorry, of Paintbrush. I don't even know the software, so forget about it. So when you perform a regression or a forecast, you are relying on current transactions, right? On current transactions. And you say, okay, I'll establish a goal. I establish a goal, which is going to be $1 million. Actually, the column is above. There you go. $1 million, right? But you have some historical records so far, correct? What it means that all this area behind, which is, let's imagine this. Let me put another here just to close the shape. Imagine that all this just behind or in the left-hand side of your line, of your limit line, these are your historical transactions, right? These are your historical transactions, something that already happened in the past. And based on those, you are performing this regression, right? Where you are actually planning to achieve the goal or $1 million. However, what is going to happen if at this point you perform another linear regression or another non-linear regression? What is going to happen? Most probably, now that it is using more historical records, the prediction will be different, but not realistic based on at the point where you actually decided to perform the regression, right? So it can be kind of biased based on the latest and greatest transaction that have taken place, correct? Because the standing point, it won't be here anymore. It won't be here anymore. It will be here, and the behavior is totally different, correct? Crystal clear so far? That's why you only perform the regression at certain period of the year. You don't do it over and over again, right? You are only comparing how are you doing based on the forecast that you made. Instead, you use the logistics regression. So the logistics regression, what it's gonna do? Instead, it's gonna take all these patterns. It will take all these patterns, and based on that behavior, it will take the upcoming one, which would be this, right? Let's say that you want to evaluate, let me change the color. You want to evaluate a layer on, right? I told you, right? If you perform a linear regression here, would be totally different. So instead, you perform a logistics regression to analyze kind of that difference that you will have in the trend in this period. So the trend in this period, it's slightly different, right, than the trend that you had here. Crystal clear? Now, does it make sense? So in other words, the logistics regression will let you know whether you achieved or you are at this point, whether you are going to achieve yes or no, based on what have you planned with the non-linear regression. Crystal clear? In other words, to prove at that current standing point whether you're going to achieve it or not. That's it, based on the regression that you perform at the beginning of the fiscal period. Makes more sense? That's why it's always suggested to use the different models as a complement of what has happened in the previous model. One of them establishes the goal, and the other one helps you to identify a review and understand the health, kind of the key performance indicators around what you have forecasted or what you have anticipated that is going to happen. Is there any question so far? This concept is important just to let you to understand what's the difference between, because you may wonder, why are we performing a logistics regression if we can do a nonlinear regression or the other way around? No. The most basic is the linear regression. Afterward, the nonlinear regression, and afterward, you use the logistics regression to start evaluating whether you are achieving the goal over periods, yes or no. So good so far? Okay, beautiful. Now that we have touched that point, that's why we would use the logistics regression to analyze, for instance, the stocks in the market, right? Because those already have historical records, and we do not expect them to behave pretty much the same or linear, right? Those may go down or up. So the logistics regression would help you to identify whether you are achieving the goal that you established for your stocks or not. Let's imagine the example of Oracle, right? That I may say that Oracle stocks next year will be $150, while now is $102, right? That's my projection. However, with logistics regression, I can evaluate period by period whether that is feasible and at what percentage it is feasible. Pretty much. So in other words, if I see that the percentage is decreasing, that means that I won't achieve the goal. I have a problem there. So either I need to reshape my forecast or I need to change my strategy, my company in order to achieve the goal. So that's why these processes would help you to understand not only the projection, but also what you can adapt based on the patterns and trends that you have identified so far to see what tweaks you need to make to start creating a better analysis. So that's why you need to use a mix of all of them, but need to make sure what strategy you need to follow with your data, right? So for instance, in something else, we use something called the confusion matrix. The confusion matrix is nothing but now, once that you have performed certain projections, right, the logistics regression would help you to identify based on those historical records that you anticipated that are going to be, let me give an example. We have good and bad, right? Let's imagine that with your linear regression, you anticipated that based on the actual, it was about to be good also in a prediction. But you anticipated that another transaction would be bad in the future, right? So you have a good, and the bad, which means something that you anticipate is going to increase actually increased, and something that you anticipated that was to decrease decreased, right? Crystal clear about what is a positive and negative, or the optimistic positive or the negative pessimistic, something like that, right? Something that you anticipated is going to be good, actually you predicted it. So in other words, the logic would be, did you predict it well, yes or no, no matter whether it's good or bad. So if you anticipated that was about to increase, good, and actually increased, perfect, you made a good prediction. But if you anticipated that something was about to decrease and actually decreased, guess what? You have a true negative. However, be careful with the mistakes or the errors. When you anticipated something that was about to be good but went bad, then you have a false, actually, it must be false positive, actually. Anyways, or, well, here they put it false negative, false positive, and true negative. Okay. So something that you anticipated that was about to be good and actually you predicted that was bad, we need to wait until that happens, right? If you realize that you anticipated that was good and is bad, guess what? And it's an error in your prediction. And something like that happens with when you predicted something that was about to be bad. And well, fortunately, those are the good news, right? That they want to receive. If you anticipate something that was about to be bad and suddenly it's good, well, guess what? You're fine, right? So this is the confusion matrix. In other words, actually, let me explain it with Excel. The confusion matrix is nothing, because I think this image is not crystal clear and I don't like it. I need to change it actually. But let's imagine this scenario, right? You have a prediction. You have transactions, right? Transactions, and you have pretty much two types of transactions: either positive, which means a transaction that went from 2 to 3 or something like that, and negative, right? Something, for instance, that it is from 3 to 2. For instance, what do you want to reduce over time? Mistakes, expenses. You want to reduce errors. You want to reduce, you always want to reduce something in your business. That's a reality, right? And however, you want to increase things, like, for instance, revenue, profit, efficiency, or headcount, and so on and so forth. So you have two logics. So you have the one thing is the prediction, and the other thing is the real world. So let's call it this one, prediction. Let's call it reality or real transaction, right? So you anticipated that actually something was about to be positive, and guess what? It was positive. And then this one is a true positive, correct? Why? You predicted it was about positive and it turned to be positive. You have a true positive. Same thing. You predicted something was about to decrease or to be negative, and you put it in actually is negative. This is a true. What is going to be the logic? True what?
True negative.
True negative. Exactly, because you anticipated something that actually happened, right? Okay. However, what is going to happen the other way around? Let me copy this. Something that is a transaction that you actually, I misspelled here, but anyways. So a transaction that you anticipated that was about to be positive, but it turned to be negative. This is a false what? Positive. Exactly. That means that we have an error here, right? And what is going to happen the other way around? That you expected something to decrease and suddenly increase. Perhaps it may be an optimistic transaction, so on and so forth. So this one would be a false what?
False negative.
There you go. All these two are the ones that we want to avoid. Why? Because if we're predicting something, no matter whether it is good or bad, it must be a good prediction. That's it. Correct? If my prediction is not correct, are two different stories. First, if the prediction is not correct, my model is not correct, or my data is not clean, right? That would be the first thing. But if my predictions are correct, guess what? You can actually take decisions. However, there's certain level of uncertainty or certain level of errors that are accurate. Usually, a model that it's accurate must go between 85% and 99%. That's something that I may suggest, that it's a accurate model. If it goes between 85 and 99%, it's a model that is accurate. So far, to be honest with you, I have never seen a model that is 100% accurate. Never in my life. Never. Why? Because there's always certain level of error due to the nature of data, or due to the nature of seasonality, or due to the nature of something else. Crystal clear about the confusion matrix and how to identify it? Why am I telling you this? Okay, now let me tell you why. Let's go to the fun. Is there any questions so far?
Yes. So, so with those models that we've been doing, I remember some of them had like 97, 98% accuracy. So that remaining 3%, that will be, if we get an answer that it's a false positive or a false negative, that will be that remaining percent, right?
Yeah, you're totally right. Very good question. Very good question. For instance, let's say that you have 100 transactions, right? Let's say that 50% were positive. Let's say, actually, let me reduce that. Let me say 45%. Let's say 53% maybe. And how much do we have here? 98. And let's say that 1% and 1%. So what it means, actually, let me turn it to 2%. Dot 0.1, right? This will give us more than that. So yeah, dot 0.1 because it's 1%. There you go. So this will give you 100 of your transactions, right? So in other words, let's give this example. Out of the 100 transactions, 45% of them were positive, 53% of them were negative, which means, so if we sum this up, it would be this plus this. No, I made a mistake. I'm sorry. E2 plus E3. Sorry about that. Plus E3. Right. So 98%. And usually you sum the negatives also. Right? So in other words, these were bad predictions, but guess what? Actually, the real, you may think the real accuracy is 98%. No, it is not. The real accuracy is based on the comparison between both. And this one is pretty much like kind of 97.08%, right? Which is something above 85%. It's a very good model. Actually, something above 75% is a good model, acceptable. So if you bear in mind that the way that you take decisions, it's based on two things: experience and facts that you get at the moment, right? It's pretty much, correct me if I am wrong, or correct me if you think that there's something else, but pretty much is the facts that you can see there and your experience. So what is helping you these models to let you know that this prediction, if it's 98%, guess what? You can use 100% your feelings or your experience to take decisions. You don't have to distrust in data, because data is telling you that you are going to a certain direction, right? At the end of the day, the decision must be taken by you. But but responding to your question is, how many of those true positive, how many of those true negative? That means it's divided by, the errors, which is the negative positives and positive negatives, are divided by the total of correct predictions in order to identify what's the level of accuracy of your model. And it's something I'm going to show you in the code, just to give you an impression about how it works.
Hey, Professor, can I ask something?
Yes, please, go for it.
Sometimes like the recall, like that metric is more important than the accuracy, depending on the call to action that you have. So to give you an example, in the business that we have like customer success managers, right? And like the cost of hours of them could be very high. So you can have like a model that predicts like 95%, but if those errors are so big, they will have plenty of accounts, right, that they could not manage. So in that case, we need to understand the cost side and also play with those errors to see what makes sense, because the most important thing for our case is just to earn more money. So
that's a wonderful point. Thank you so much for that addition, because yes, sometimes you must rely on keeping a customer or keeping a customer happy rather than earning more money, right? So at the end of the day, here also would help you out. It would help you also to understand how much risk you can take. For instance, if you perform a regression and you know what, we're gonna earn $1 million, and suddenly your best customer is asking you for a discount higher than usual. Why? Because they are telling you that they are in a difficult situation, but certainly they will recover, right? Or maybe they ask you for more credit, right? Sometimes you may think, okay, usually the rule would be no, right? Why? Because it would affect my numbers. But sometimes to keep a long-term relationship, and it's something that you can create a contract around that. I mean, I don't know how your company works, but sometimes you may need to take other decisions in order to keep the long-term relationship for that customer and to make sure that it won't be only $1 million, but it would be $1 million for the upcoming 10 or 20 or 30 or 50 years. If you establish a long-term relationship, right? Because that customer will feel grateful with you, and he would return back the favor somehow with loyalty. So thank you so much. I mean, is that is related to what you said, right? But in a different example. Am I right or correct?
Yeah. Another example, but yeah.
Yeah, beautiful. So that's it, yeah, right? That's why I'm telling you. This only would give, on despite it would be perfect prediction. Either way, you need to take decisions out of that. And some of those issues may be also to get rid of a customer or not to selling anymore, right? Because I don't know, they haven't paid or so, or maybe taking the decision to change to a different supplier, or maybe reducing the amount of suppliers would be another decision that perhaps later on with clustering, you would identify which are your best suppliers and get rid of the outliers or things like that, right? At the end of the day, the tools would be your facts, but you need to take those facts and take the hard part, the decisions, right? That's why I think that a machine never would take the ownership of a person. Why? Because what if that, I mean, unfortunately, people can be sued, right? And we can go to jail. But if you were a company and your machine makes a mistake, what is going to happen then, right? Who is going to be who needs to pay the bill, who needs to go to jail and so on and so forth, right? So there are a lot of ethics around using these models, but at the end of the day, it must have a person who actually takes the decision. So this time around, let's take another example. Do you remember that we performed a regression, but using categories? Do you remember that? Okay, today we will take a look to a regression, but using dates. So which is something more related to you, right? So let's take this example. I actually, this time around I use set seated, so you only need to change it once, and later on you can change the data set and so on and so forth. But this is something you're familiarized with. Invoking the dataset. So what's the dataset about? Okay, the dataset about, let's take a look. Okay, as we can see, we have dates, start, end date, and date. What it means? So it means that start and end date means perhaps is the period where you start establishing the transaction, right? Because you also establish, you have quarters, sometimes you use months, and depending upon the business, can be also weeks, right? Like in manufacturing. In manufacturing, you measure everything, usually daily, and you perform a summary by weeks. But again, depends on the manufacturer. If it is different between cars, and than talking about cell phones, right? The volume is totally different. So depending upon your business, you may use different dates, right? That's why I usually use the three of them, start, end, and the real date. So in here we have values. Value, what can be? Can be you sold a car, maybe. This time around, it's gonna be cars. You are selling cars. So between 1992 and 2018, you are establishing how much cars, how many cars you sold, and you would like to predict how are those what is gonna happen with those transactions or that volume in the future, right? For instance, we have here so many dates between also 2018, 2017, 2008. I mean, we have so many transactions for cars, right? So what we're gonna do here, well, this is something you are familiarized with, right? We invoke the data set, which is called binary. And afterward, if we use the method head, do you remember what head is gonna give us?
First list of records.
The what, I'm sorry?
The first list of records.
There you go.
First.
Exactly. Beautiful. It's gonna give you, well, this one, it must give me, actually my data, I'm sorry, I have not invoked it. There we go. This one will give me the X number of records, the first records that I established, right? In this case, it gave me the first 6 records, but I can establish as many as I want. However, you don't have to change it. Why? Because you only want, this one is gonna give you only a sample of your data to understand what's the behavior of your data, just to give you a quick side. Why? Because what if you have 1 million records? Can you take a look to 1 million records at once? It's gonna take a while, right? Opening an Excel file with 1 million records, how long does it take? right? Sometimes, and you only sometimes need to understand what are the headers or what are the first line to understand what is expected for the remaining line. That's why you use the head to get a sample of the data and understand how it's working. Also, you can use summary. You have used it before. That will give you statistics around your data, right? I won't elaborate on this. But this time around, actually, you know what? I'm sorry, wrong one, wrong example. Apologies. So this time around, I mean, this is the cars one. So I use the view data set, and afterward, we will create categories. Do you remember that we talked about levels? Do you remember when we talked about levels in R? What those were used for? The levels.
The different values of a certain category.
Beautiful. So in other words, you can establish the levels of transactions, right? For instance, you have transactions of millions of dollars, and you would like to classify them based on what are the different levels. Let's say that you have between let me make it something smaller. Let's imagine that you have transactions between $1 and $10, and you want to classify them, or you would like to establish bottom transactions, which would be between $1 and $3, mid-sized transactions, which would be between 3 and 7, and big transactions, right? That can be between 7 and 10. So you create those categories in order to classify your information based on those thresholds, right? So you establish 3 levels to understand transactions between $0 and $3, second level between $3 and $7, and last level between $7 and $10. Crystal clear? And you can call them small level transactions, mid-level transaction, and big transactions, right? To give a name. So you create those categories in order to classify your data, but only using their limits. Crystal clear? Okay, I anticipate that it was a yes. So in here, we are creating a subset. The subset, we are taking the subset, if you remember, is a smaller amount of data, correct? Where actually we use only 2 columns, right? So in this case, I'm establishing a new vector, which is based on the higher data set, but by using the subset, I'm letting it know that I'm shrinking the amount of columns of data that I'm using, right? The subset means creating a smaller amount of data set. I will use the data set that I established, and guess what? I will only select a vector. The C stands for a vector, and I'll choose only date and value. Crystal clear about this transaction or about this method? Now let's take a look to that particular method, and let's see how it goes. Little typo. There you go. So now I can see that I only chose date, which is the actual real transaction date, right? And chose value, which is nothing but a matrix with these 2 columns. Crystal clear?
Yeah, Professor, sorry.
Mhm.
Then here in R, the select word works similar to SQL, right?
Beautiful, exactly. It's like where if it were the select from dataset, right? Select data and value from dataset would be kind of the equivalent where, well, the where, it will depend on what filters you include. But yes, it pretty much, it works exactly the same as it would work in SQL.
Okay, thanks.
Good question. I've never received that question before, so beautiful. Anyways, so exactly, here we are establishing a new data set, right, with only those 2 columns. Why? You may wonder why. Okay, guess what? If you remember, have you worked with Excel before? I think you have. Have you faced issues dealing with dates? Like sometimes the date is not taken at the date itself. How other formats is being taken?
Numbers.
Numbers. There you go. Text. What else?
Characters.
Characters. And what if the file is being delivered from Europe or being delivered from the US or being delivered from South America? Have you faced an issue dealing with dates?
Yes, it's different. the months and days.
Exactly. That's why here, first you need to perform a data cleanup, right? To standardize the format. And here you need to do something else. You need to establish for the code to let it know that column, which is called transactions date. I'm sorry, the column is called date from the transactions table, which is the latest and greatest that we created. We will manage it as date. Do you remember that we used the as before, as date, as integer, as decimal, and so on and so forth? Here we are forcing that column to behave as date. We are forcing it to behave as date. Else, it can be strings, can be detected with different. Actually, you were right. It can be detected as character, it can be detected as string, can be detected as text, can be detected as something totally different than a date. So with this instruction, you are forcing that column to behave as date, right? Afterward, we're invoking, or you are aware of this, we are invoking we are setting the seed, which means it's going to use integers, right? Only into the between maximum and limit value for that particular transaction state. Afterward, you're familiarized with this, right? Let me rephrase that. What are we doing here with the sample split? One volunteer.
With the sample. Sorry, this was the one that you were using, like of the sample one. You were using in this case, 2/3 of that one, right?
Beautiful. Actually, it's 40% of the data.
Oh, no, yes, 40%.
Yeah. So what we are doing, we're only taking random values, 40% of the random values to understand or to train our model, right? Well, so far we are only taking the sample, right? Is as you have let's say 100 marbles, and out of that you take 40% of them and try to understand. Oh, you only take 40% of them. Is what we are doing. You have 100 marbles, and here we're saying, well, out of the 100 marbles, only take 40% of them. Crystal clear? Afterward, we are saying, okay, we are gonna call it training set, which means that, okay, now that you have established here, we only say, how much are we gonna take? 40%, that's it. That's what we are doing here. However, when we say split true, is actually taking the 100% marbles and getting the real 40% of those. So it is actually taking those 40 marbles, right? And then will be 100 minus 60, which would be the 40 marbles. This is the instruction, and this is where actually it is taking the 40 marbles and analyze them and assigning it to this object. Crystal clear? Beautiful. Afterward, well, actually, this is repeating. It's pretty much, this is only to be the training set. I mean, it's repeated. I'm sorry, this is a test set. My apologies. This is a test set where actually it's going to take all the 60 marbles, right? The remaining ones, and say, you know what? Once that we have understood this 40, now let me see whether actually is the same situation for the other 60, right? Let's say that this one said, you know what, are 40 marbles, where 20 are green, where 20 are yellow, and that's it. That's it, right? Let's make it a little bit more complex. 10 are yellow and 10 are red. It's kind of, just to give an example, it's a silly example. But in the training set now, only took 40, right? Now in the training set, in the test set, it's going to take the other 60 and say, you know what? In the other 60, guess what? 20 were green, 20 were yellow, 5 were red, and guess what? 5 of them were, gray. 5 of them were gray. So something that wasn't part of the original sample. So this can be detected can be detected as an error, as a bias, and it may happen. Why? Because if the sample is too small, it will be difficult to take it as part of the overall. That's why it tries to describe your entire model based on the majority of the values. Now it's clear about what we're doing here?
Professor, just to be sure, so there's no pre-processing to try to balance the classes in the test data set. So it basically, it is ordered, it just take like the 40% for training and then
Random.
6. Okay, but
Random.
there's no pre-processing to try to balance the classes or the levels as you refer to, right?
It is being performed in the data cleanup that we took a look to the first class, but only that's a very good point. Yes, else it would be manipulating the data. What we want is to make it standard, so the algorithm can read it. That's what we do in the data cleanup, right? That we get rid of weird values, or we get rid of weird characters, or we get rid of something that is not useful for the analysis. However, in here, based on the data that we consider trustworthy, now we take the samples to understand how is the data behaving. And it's a 40% random values. You cannot force the algorithm to choose specific specific values. It will take random values to help you to describe honestly how is your data behaving. Is random chosen?
Thank you.
Good question, Emmanuel. Thank you so much. Afterward, who can explain me here the regressor object? One volunteer. Do you remember what the regressor model used to do? If you don't remember, don't.
It's creating like a model, right? Like a predictive model.
Yes, yeah. But what kind of model is this?
It's linear.
There you go. Beautiful. It's a linear model. What else you can see here?
You're trying to predict if in a linear model, how value is dependent to the date.
Exactly. And what is it using? What is it using to perform the prediction?
The data set that the training set that we trained.
It's using previously. That as a reference. So if you want to rename it, it is using the data, is letting you know what is it using as a reference. Beautiful, exactly. Someone else that would like to add something else to this object, that would like to add your inputs? That's it? All pretty good explained? Everybody's clear in this object? So in other words, thank you so much for that. We will use the value correlated, or looking for a correlation with date, which is what it means, this virgula. I'm not sure how to say in English, but in Portuguese is virgula. So, and I think in Spanish is the same, virgula or something like that. I don't know. I need to look for that name in English, actually. My bad. So we use this symbol stands for it's related. However, if it's correlated, the projection would be accurate. If it's not correlated, would be totally different, right? Sparse. So, however, here we assuming that those are related, are correlated, right? Afterward, we're saying, okay, you are gonna use the training set to analyze all these values and create a trend out of that. That's what we are doing here. So in here, but so far we have not created the dependent variable. We are saying only how is the data expected to be related for the model. Afterward, we say, you know what? Let's create the y-predict, which is gonna be the dependent variable. So the dependent variable will use the test set, which is the other 60% of data that we did not take into consideration into the training, and now apply this model and let me know how is it working. How is it gonna behave? Well, if my training was correct, then this data must behave pretty much alike, is what we are saying here. Okay, Now, okay, I have to run them, so let me run them just to make sure. Let me take a look here. Okay, what is not training set? Training set is not declared. Training set, of course it is. Come on, don't be like that. Okay. Actually, I'm including too many comments here. Yeah, let me keep it and comment it. Comment. So now let's run all this first in order to create the sample to let it know, okay, you're going to take 40% of my data to understand it. Afterward, understand it. How is that 40% behaving? Afterward, apply the same for the remaining and make sure that those are pretty much alike. And afterward, perform a prediction for the entire 60% remaining of my data. So far, all the objects are created here. The regressor, let me go one by one. First, the training set, right? Here it says are 128 objects, right? Why is the smaller one? Because we said only take 60% of 40% of that. Afterward, we created the test set here, which is nothing but applying the same to the remaining objects, and it's creating two objects differently, right? Afterward, it creates the regressor, and it takes all the training set values and applies the model over and over again to understand how are those behaving and what is it doing. First, well, actually I explained it already, but I really want to make it totally 100% crystal clear, right? So what is it doing? First, we have our projection, right? Let's say this one is linear regression. So what it means is a freaking line, right? So this is the regressor. The regressor is this object. So let me rephrase that. First, we're going to have the objects, right? We have the first training set. The first training set, yes. The second training set, the third training set, the fourth, the fifth. And thus, let's include only 4 to let you know that actually is 4 out of 10, right? This is a training set. So based on that, what it does, okay, it says, okay, the distance between this and this is this, right? And the distance between this and this is this, the distance between this and this and this, and so on and so forth, right? It creates relationships among all the objects or all the dots in order to make sure that it finds the exactly middle point between them, which would be perhaps something, I don't know, something around here, right? Something around here. Let's say that this is the middle point, something around here, right? And afterward, it will create, it says, okay, now your model is trained. Now I know that the middle point of your transactions is here. So if it started from 0, it would be this trend, something like this, right? Because this is the middle point among all the middle points. So it created the regressor out of that. Afterward, it will test the test set. The test set will be blue. So now, okay, it's a circle, right? So we have the test set and takes the first value, the second, the third, the fourth, the fifth, and we will have one crazy guy that it's going to be in here, right? Just to give an example, this guy is an outlier, but so we will ignore it. But if we want the kind of a close prediction, is this one. So what is going to happen? How is that going to test the accuracy? Based on the middle point, which is this point, let me change the color. It will measure, okay, how far it is, 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 how far it is. So in other words, as closer, as more accurate. What would happen if we have a dot right here? Oh man, this is gonna kill the accuracy of our model. So either we did something wrong, or this can be, I don't know, fraud, or this can be, I don't know, bravery. It can be something that may pay, or we must pay the attention. That's why this error may increase, or this transaction may increase the inaccuracy of our model, right? Is now clear? how it works? Go for it, Guillermo.
Sorry, Professor, should that be considered an influential point or an outlier?
It depends. That's a very good question. And I would say it depends. Usually, for training the model, what I would tell you, get rid of that. For me, it's an outlier and it's polluting my prediction. Why? Because with the test set, with the train set, it told me that is this train. And if it goes here, for the accuracy of the model, get rid of that. Get rid of the outliers. However, for business purposes, pay attention to that one because it may mean something important for your business that is not related to the prediction, but maybe affecting maybe your company's reputation or your forecast, or someone is stealing from you, or I don't know, something like that. It means something, of course, but for the sake of the prediction, get rid of that thing. Get rid of it. You don't need it for the prediction only. Crystal clear?
Yes, Professor. Thank you.
Beautiful. You're welcome. So guess what? Now we will see how it is behaving. So let's do that. Let's take, well, this time around, it's going to be a lines chart, right? It's a lines chart where actually it's going to project how is our model behaving. So guess what? We can see, here we can see seasonality. Who asked me about a model with seasonality last class? I forgot, I'm sorry, I don't write it down. But someone asked me, how can I identify the seasonality? That's why I included this model to show you, guess what? Here in 2010, we have seasonality. Why? Well, maybe several reasons, only your business knows. But here I have identified that I have seasonality. Oh, this is only for the training test, for the training. Now let's apply it to the remaining 60% of our transactions. Guess what? Pretty much alike. The behavior is pretty much alike. So we can see that our prediction will be really close to reality. But now I have included a new object. What if scenarios? Let's take a look. Here we have only transactions until 2020. What if you want to predict what is going to happen in December 1st, 2025? So let's run that prediction. And guess what? It's going to give us that, okay, you're going to have $80,000, 588.03 cents. So this is the power of these objects, right? That not only will show you a trend, but also if you've used the prediction, a single object for a particular category or for a particular point in time, it would give you with certain level with accuracy what would be the expected return for that particular transaction. Crystal clear? How do you find this model? Do you like it? Do you dislike it? Do you find it useful? You think you can use it for your own purposes? For me, has helped me a lot. It's so powerful. It's so powerful because I can prove to my business, okay, based on the transaction that we have had so far, we're not going to achieve the forecast. And why? Because up to this point, first I performed a linear regression, afterward nonlinear regression, and I've been testing or projection based on that. And I see that I want to achieve the goal. Why? Because in this month, I mean, you can include months, quarters, whatever you want. Here I included years. Why? Because it's too much data between 1995 and 2020. That's why I included years only to show you what's the trend of your business over periods, right? So you can use it in many different purposes. You can use it in many different fashion, but it depends on your business. It depends on what you would like to show and how would you like to show it. So if there aren't further questions, let's go to the model that we discussed today.
Professor, for that explainability that you refer to, we need to check like the coefficients, right? How they are tied with the R square, with the, like as we did in the homework, right?
Exactly. Exactly. Like for instance, do you remember what we used to view those prediction or to view those accuracy levels? Do you remember?
Summary, regression.
There you go. There you go. You use summary, and here you can see, I mean, you can use describe, summary. There are others, right, that you can use. I suggest you to use all. Why? Because each and one of them will give you different data. And yes, answering your question, yes, with this one, you would be able to evaluate whether it's in a good shape or a bad shape, or whether it was a good prediction or it wasn't a good prediction. Something that honestly, when you do your forecast manually, is difficult to evaluate. Go for it, Roberto.
So for both plots that we have already done, if, one can say that you might choose or you might done a good prediction when they both are similar, right?
Exactly. If you test similar models and you see different behaviors, you have a problem. On despite these measures look accurate, but that's why it's important. With these models, you can evaluate everything. Quick side, how is it behaving in a graphic matter? Afterward, you take a look to the numbers and compare among the numbers to understand how much trustworthy the information that you're going to give to your business is, right? So as more, I mean, if you can see the charts are pretty much alike, right? That you take a look to the training and the test set, and those are pretty much alike, that's a good comparison. Afterward, you take a look to the numbers, right? To the statistics around your data. And you think, okay, well, there's not that much variance. The mean is pretty much between exactly the maximum and minimum. That means that we don't have those many outliers. The first quartile, well, is pretty much accurate, and so on and so forth. It's a trend that actually you can identify here, quick side, right? And you use other, and those are the other facts. And last but not least, your experience based on your business, right? Which is gonna be kind of the cherry over the cake, because you're gonna take all this, using the power of information that you already can digest and the knowledge that you have in order to let your business know where to be driven. Where to be driven to. Beautiful. Very good question. Okay. If there aren't further questions, let's take a look. Let's take a look to the logistics regression more. This example, it's really interesting. Imagine that you are working for a university. To the process of accepting the students, and you would like to create a criteria about what's are going to be the thresholds where you accept a student, yes or no, and to predict out of your students that are going for the same university to another university, how many of them are likely to be accepted, and at what level. Because someone who actually applies to a university, right? And let's say the acceptance level is 600 points. If someone gets 601, pretty much is accepted unless the criteria changes, right? It may happen. At least in the university I used to be studying for, and we have two different calendars, A and B. The B calendar is the one that has the highest thresholds, and the A calendar used to slow down a little bit, right? Go 5 points less. I mean, I studied at Guadalajara University when I started my bachelor's. So it was the threshold. However, there were some ones who actually was really good in math, really good in English, really good in Spanish, and had a really good average GPA, right? They may get 800 points or 799, taking into account that the maximum was 800, right? So either way, both are going to be accepted. However, one has more likelihood to be perfectly accepted, which is the one who actually has the highest value, right? However, the one who actually pasó de panzazo, right, would be in Spanish. I'm not sure what in English there's a same saying, but for the one who actually was the panzazo, there's a risk that in case for some reason that period that increased by 1 point the average for acceptance, guess what? It happened to a friend of mine. For 1 point, he wasn't accepted to bachelor's degree. So, and it happens. That's why it's important to understand the likelihood of something. This is exactly what we are doing here. We're based on let's imagine that we're in a university, right? And we would like to accept certain students, a group of students. We can perform a logistics regression that out of the entire population of students, how many of them are likely to be accepted and how many of those aren't likely to be accepted into a university. I mean, I tried to show you different examples just to try to adapt to your different industries where you work for, right? So this example, actually, let's take a look to the data. Let's take a look to the data. So view and my data. Let me see whether I invoked it. I think I did a couple of times, so I just want to make sure. There you go. Let's take a look. And guess what? We have whether this is historical records versus admission, right? This is the GRE, the GPA, and the rank, right? As I told you, maybe two of them have the same GPA. However, they may have different rank depending upon other factors, right? You can include as many factors that you may think of. I'd include the GRE and the GPA, right? Which is the GPA is nothing that what was the grades from college, and the GRE, how much they can get out of the test, out of the exam, right? So we can rank them. You can or you cannot include the rank. It depends upon how many factors you want to include as part of your decisions. This time around, I included it because I have my students ranked based on other different factors, right? So in this case, let's take a look to the summary data to see. Okay, we can see what's in the minimum. You can see that is 0, the maximum, and what are the different categories that I have created based on the rank. Afterward, I call it the logistic model. Here I wanted to show you something interesting. How do you may wonder, how can I include other factors? Because if you remember in the linear regression, we included the dependent and the independent variable, and that's freaking it. Do you remember that? And actually, we can take a look to that. If you remember, we took or we included either dependent and independent variable, or we included the two categories. First, the facts, and second, the category to be taken into account, right? In other words, what are the relationships that actually gives the power to the result? Crystal clear? So here that I just wanted to show you that you can include other factors. How we can do that? You can sum them up or multiply them, whatever suits you better. I won't tell you what to do here. It depends on every situation, and it depends on the nature of your information. Because I'm not sure whether it happens to you, but many people tend to say it applies for everything. No, guess what? No. You need to use your experience to adapt the models to make them more accurate based on your business. So in this case, I'm including the GRE, the GPA, and the rank for my projection. However, guess what? In this one, I'm saying the family. I'm establishing the family. Here I am saying binomial. Binomial means either one or the other. Yes or no. Pass, does not pass. Something like that. Crystal clear? Either accepted or not accepted. Like when you go to your visa and it gets accepted or denied. That pretty much it. So that's why is it called binomial. Binomial. There you go. So I'm applying the model to my entire universe of data. And afterward, let's take a look to the summary. Well, it's pretty much something you're familiarized with. So we can see that we have the intercept, which is nothing but the middle point of the entire data, right? We can see the significances, where actually we say that for the p-value, it must be something less than 0.05, right? If it's something more than 0.05, means that there's a huge amount of differences in your data or error. So this is the p-value. Pay attention to that. So afterward, the deviance and the AIC, this one, I'm not sure what it means, to be honest with you. I may need to research. This is something that I'm going to research, but I don't know what it means. But it's something, let me research. And we can see the Fisher scoring iterations. That means how many times it run all the data to let you know the accuracy level, right? Afterward, well, let's take a look to the probabilities. Please pay attention to this. I'm sorry, we haven't run this. So afterward, well, we run the predicted probabilities. What it means, it will take all the it will take the model and it will apply a response. What it means, it will take your data here. Let me give you an example. Let's say that we have GPA and we have score. I don't remember the name that I assigned and the rank, right? So let's say that you have a GPA here of 3.0, 3.4, and so on and so forth. And the score, we have 9, we have 10, we have something like that. And the rank, we have 1 and 2. So what is it going to happen? So we're taking this particular example. So based on the response is nothing but, okay, based on the combination of this one passes, right? Which is going to be a 1, and this one does not pass. So it's going to be a 0. So this is going to be, we called it here response. So this will be the response. So based on the established thresholds, it will, this one did not pass. So that one does not pass. And this one actually passed based on the combination of the factors. Crystal clear? It is nice, isn't it? Well, so good so far, at least. Okay, now that let's do that. Let's apply. So we are creating a new column, which is predicted probabilities, and we will include whether it passes or not. Okay. Not here. Let's predict. Actually, it's the same thing. We will create. Well, I'm not sure what I'm going to repeat this, but it's pretty much the same. My data. No, you know what? I'm sorry. Here we are creating the probabilities, and here we are applying the model, the data. We're applying the model to the data, right? Because here I am invoking my data. So I am taking the entire universe of what I have in my records and applying the model to that. One thing is the response, and the other thing is actually applying. I'm sorry. One thing is to create the limits, and the other thing is to apply the same models to iterate those models and apply whether 0, 1, 0, 1, 0, 1, 1, 1, or 0, 0, 0, and so on and so forth. Afterward, we will create the classes. Here is nothing but creating the 2 levels and classify them, right? Because now what is it going to do? Now it will say, okay, those that pass, it will go here. For instance, Fer passed, Omar passed, Gonzalo passed, and so on and so forth. But those that actually did not pass, let me give you just, I don't know, Simona, Glenda, and so on and so forth. Actually, this is biased. Why women did not pass and male passed. So usually the ladies study more. I'm just kidding. But let me reduce some gender thing bias. There you go. The ladies, more ladies passed than men. I mean, just one example, right? So that's exactly what we're doing here. We're establishing, depending upon which one passed, those are being classified based on if it passed, it's higher than 0.5, but if it did not pass, it's lower than 0.5. That's a way that it classifies it. Okay. Afterward, let's perform the confusion matrix. You know what? I have not declared these classes, so let me do that again. And let's take a look to the confusion matrix. So the confusion matrix is nothing but what I told you, right? Something that was predicted that was not going to pass. 253 actually did not pass, but 98 actually passed, right? And for those that actually said that we're about to pass, only 20 did not pass, and actually 29 passed, which means that the accuracy of my model is this plus this, I'm sorry, this plus this divided by the total, this by this, right? So, but it's just to give you, this is nothing but to compare. Was predicted not to pass, 253 did not pass. Those that were predicted to pass, only 29 passed, right? Crystal clear about the confusion matrix? Takes a while to understand, honestly. On this part, I look like an expert now. It took me years to understand all this code. I'm trying to summarize it to make it kind of clear for you, something I would expect it from someone directed to me. So hopefully it helps you to digest it even faster. So this is exactly what we're doing. As we can see, well, it's pretty close to be perfect, which is gonna be, it will be 200, actually it would be 29, I'm not sorry, 20 plus 20 plus 20 plus 98 divided by 253 plus, actually it works in Python, hopefully it works in R as well. There you go. I can see, well, the accuracy was 58%, which is not exactly something really good, yet it's acceptable, right? 58%, it's acceptable. Honestly, for me, some would be something 65. Why? It may be that there may be some errors, or maybe we need to clean up the data a little bit more. Remember that this is faking data, right? This is data that I just make up for your course, so it's not exactly something real. That's why it has that highest level of inaccuracy. But just to give you an example. So for instance, now let's measure. I create another formula here to create the accuracy. And now it says, let's print it out to see how close it is to the calculation that I made, right? Because it uses a little bit more logic behind the scenes. Well, it says that it's 70% accuracy, which is higher than what I calculated, which is better, isn't it? So it says that my model has 70% accuracy, which is good. I told you something higher than 65% is something closer to reality. Okay. Now what we're doing here, well, we're going to print it out, that particular accuracy model that tells us is 71%, right? So afterward, what if we test one scenario? Let's say that a new student comes across and give us their papers. You tell me the numbers. What is going to be the GRE? Let me rephrase that. Please give me the numbers for someone who you think that would be accepted. What would be the GRE?
600.
600, beautiful. So you think that person will be accepted?
Yes.
Okay, Samuel. What's the GPA?
3.2.
3.2. Let's use that. It sounds kind of riskier, right? Sounds kind of riskier. Well, the rank here, let's say that it's rank number 2 due to the numbers, or it was ranked based on students. And let's see whether that person was accepted or not. Okay. So let's create the probability model. And let's see whether that person was accepted or not. And he has 33% to be accepted. 33% to be accepted, which is less than 50%, which not even with a flip coin, he'll be accepted. Can you see the power of this model? So as you can see, it helps you to evaluate with a single first, based on pass or not, it will give you the probability that that person will pass or not. So here we have the probability of 33% that that person will be accepted. It's too low. It must be something, at least for a university, at least higher than 50%, at least. But it requires more than that. So do you like the logistics model? Do you find it useful? Do you think it's boring? I don't know. Just let me know your thoughts. No, nothing. You're too quiet.
No, I think it's very useful and it's very interesting to find about it. I have a question.
Yeah.
You told us that for this model and specifically, we had to do the sum in the model.
No, only for this case.
Yes.
Only for this case.
What, like, I want to imagine in what case we can do a multiplication or other things.
that's a very good question. It depends on your business. Let's imagine, like, let's say that you have a club where actually you have investors. So you can say, okay, those investors have certain amount of stocks, right? However, some of them, aside of investing into stocks or they have invested, some of them, let's say that they created your first capital, your capital that you use for starting the business. So you can include a value for them. What if they reinvested in other amount when you were in a complicated situation, right? They have higher value. Why? Because they have trusted in you and helped you with that. So, and afterward, you think that you have another idea that you can implement, but you need more money. So for those who actually gave you more money, you can classify them into another category, right? You can include another column here that can be rank, GPA, and so on and so forth. So in everywhere, by the end of the year, you need to give money for each one of them for the shares. So, I mean, when they have certain amount of shares, it's crystal clear, right? If they have 100 shares and your shares increased, I don't know, 20%, so you give them 2%, right? Extra of the amount that they have. The shares will be 2%. Depends on your rules. But what if you want to give them a bonus? So you can give them the bonus based on this criteria that you summed up, and you can create, okay, first I'm going to rank them. Let's say that Samuel gave me where in the 3 situations. So I'm going to give him for him the highest value that I can give out of the extra money that I have. Afterward, let's say that Emmanuel, it's in second place, right? So we can use this criteria to be more accurate in the way that we distribute things in order to take decisions. I mean, it's a silly example. Nevertheless, there may be many different situations where you can use it.
Okay. It's
good question. Very good question. I didn't see it coming though, so I needed to make it up for to explain it better. So, okay. What if before we go to actually let me take a look. We need to take a look to we took a look to the simple linear regression with dates. We took a look to the logistics regression. We have 2 more models to take a look to. Let me show you another example of a logistics regression, but this time around using a huge amount of data, right? Not a single prediction, I mean, out of the entire data. This will be a different way to represent it and to understand another case. So let's say that we take a look to another example. This time around, it will be the same. I think the social network, we have used it before. I think we haven't. The social networks data set is nothing but based on the age and estimated salary, is to understand whether those people will purchase a product and understand what are the purchasing behaviors. For instance, here in the historical records, I know that this person has 19 years old. Their expected salary is $19,000. I'm sorry, $19,000 a year, and that person did not purchase my product. Okay, what if it were kind of unspecial, let's say insurance, right? Now, what if we take this person, the 25th, which is he's 46 years old. He earns $23,000 a year, and that person actually bought my product. These are the historical records, right? So in other words, we try to understand how is it behaving. Okay, now that I understood, we will do the same here. This time around, as per having more amount of data, we are not looking for individual classification. We're trying to classify the entire data. Here we create, again, the split ratio. Actually, the split ratio is too high. Why am I doing this? What's wrong with me? This will never work. So we said 40%, right? Would be the highest amount that we can choose. So this is another example to show you what other options you can use. For instance, again, training and test set. Afterward, the same thing. I apply the logistics regression with GLM. I include the formula. In this case, the formula is nothing but purchased and open to whatever relationship it may have, any relationship that it may have. Afterward, again, binomial is the family. As you can see, it's pretty much alike as the other, right? So here I am creating the model, only understanding my data. Afterward, I will apply the prediction to the test set, which means to the entire remaining universe of data, which will be the remaining 60%. I'll apply the model to understand it. And afterward, now it has given me, let me give you an example here. Let me show you. This will be a vector, so it won't look pretty nice, but at the end, it will give you an idea about how it works, right? For something that goes below, actually, what was the threshold between something below 50% will be a 0, something above 50%, or I'm sorry, something above 0.5, it will be a 1, something below 0.5 will be a 0. So if we take a look to here, this will be 0, 0, 0, 0. These people did not buy my product. 0.49, this is interesting, can be a yes or no, pretty much a flip coin. Because on despite it's 49, that 49, there's a likelihood to be a bad prediction. Why? Because the person can make up his mind and buy the product by the end. But my probability says that it's more likely not to buy it. This is something that you need to bear in mind, that as per being purchasing behaviors, you have no control about it. You can anticipate based on age, based on income, and based on and also gender, and based on different factors, whether the person is likely to buy it. But at the end of the day, what if the person did not carry their credit card? Or maybe that person is hesitant. I mean, there may be different human factors that your prediction cannot be perfect. Just wanted to give you an example. And for instance, here we have this guy, V22 is too likely to buy the product. And we have another one around, oh, not too many, right? Not too many, but at the end of the day, the amount of data is huge, right? So I'm just taking only a few samples. Okay, now returning back, what if we take our confusion matrix? In other words, based on historical records and based on the new records or the new sample that is taking, let's see how many of those. Let me create first the object. Why? If I didn't create the object, how come is that gonna classify it, right? So let's do that, confusion matrix. So the confusion matrix this time around, let me print it, view, CN. Let's take a look to the confusion matrix and let's see the level of accuracy. As we can see, okay, for those whom actually I predicted that we're not about to buy it, guess what? Those that I predicted that we're not about to buy, only 12 were true. For those that actually predicted that we're about to buy it, only 62 were true. For those that I predicted that we're not about to buy it, guess what? 142 are wrong. 142 actually bought it. And those that actually that were predicted that we're about to buy it, 24 did not, right? So that's kind of the relationship. So I can see that the accuracy is quite acceptable, but that's why I did not get that high level of accuracy, right? So this is only to give you an example, but again, it's random data. Afterward, what if we take a look to that particular charts, right? Let's take a look first to the training test, right? To see the training results. There we go. Here we go. It's creating the plot chart. Afterward, identifying the density. And afterward, creating the layers of the logistics regression. And I wanted to show you this to show you how it works. Right? It's going to take a couple of seconds. Why? Because this kind of chart is quite complex, so it requires kind of more efforts for the code to process it. So here we go. Taking all the transactions, making predictions, and also let me show you how it works. Actually, maybe in the presentation is clearer now. So as you can see, this is how the classification works. In other words, all the dots are all the transactions that you are taking place. So as you can see, it's a three-dimensional model. Okay, let me take it and put it into here. This is a three-dimensional model that works in this fashion. So it takes the Z, takes the Y, and takes the X axis, right? So as you can see, it's a three-dimensional model. So if we take into account the 0 as a reference, let me use another color. The first transaction took this place, right? Second transaction took this place. As you can see, it's moving into a three-dimensional model, which would be the amount invested in whether that person bought the product or not. So what happens is, imagine that we are including then, if we are performing this projection, rather than being linears, we are creating areas. So in other words, one area, let me move this. I'll try to visualize it, because as per reading a 3-degree model, I think I cannot change in PowerPoint. Okay, PPT, I cannot create these shapes. But imagine that you create the different layers out of that model, the different layers, right? This is one layer, another layer, and so on and so forth. So each one of the layers belongs to a different height into the model. So in other words, it's where actually it creates the threshold. So let's imagine that this line is the threshold. So if we transpolate that one to the remaining ones, from this point above is what can be considered the 1. And from this level beyond, it's what is going to be considered the 0. Is that quite kind of clear now? I know that is complex, because I may need to use a different software to show this, maybe by hand in the future. But this is the idea. It creates the different layers out of the entire transactions, and base that are considered above above the .5 are going to be taken into consideration as a good transaction, and those below that is going to be taken as the 0. Okay, that's what we are doing here exactly. That's what we are doing here in the code. So in other words, one that it has finished, guess what? Based on age, remember, this is a scale, right? A scale is nothing but the middle point will be the 0, which is the age in the middle point here would be, let me take the data set. I mean, I don't want to use a formula, but let's say that the middle point is 49 years old, right? So what it means that here the division is 49 years old, right? And into the right-hand side, we can see that each are the elders, perhaps. So is the people who actually is around 60s and 50s, which are going to be these people who actually has the highest income. So what it means that those predicted that based on age and income, the blue ones based on the blue area means a true prediction. The red one into the blue area means a false prediction, right? Which means this person, which actually is this age, which would be 60 years old, and this income, which would be $60,000 a year, was predicted to buy it, but guess what? Did not. Maybe that person, again, did not have the wallet, or maybe that person changed his mind. I don't know. There may be many different reasons, but that person simply did not buy the product, and it was a prediction that we made. It's a wrong prediction. And same thing for those who actually be considered that are younger and have lower income. Guess what? We predict all these that were actually not to buy the product, but we have some blue dots. What it means? Maybe that person get their, I don't know, yearly bonus, and on the spy based on our prediction, that person was not buy the product, but the person wanted and simply bought it. Why? Because they had the money at that point. That's it. Right? It happens. So this is kind of another way to visualize the logistics regression. I mean, you can perform, again, you can create a formula and perform a single projection and do that. And also we can do that. For instance, I'll use one example. Here I created an object called new data frame. I'll say that a person actually is 26 years old and earns $43,000. Let's see whether that person is likely to buy the product or not. So I run it, and let's take a look whether that person is going to buy it or not. Based on my prediction, it says that yes, that person will buy the product. It says it's a number one, and actually, no, I'm sorry. No. Hold your horses. Here, now I'm not applying the model. My apologies. I'm not applying the model yet. So here's only the object. The object is nothing but he's 26 years old, earning $43,000. Okay, I'm reshaping that data set to be a tabular view. I'm creating a scale. I'm applying the scale to that one, and let's see whether that person is gonna buy it, yes or no. Based on the prediction, let's print the prediction, and let's say a person who is 26 years old, earns $43,000 a year. Will that person buy the product? What do you think? Yes, that person bought the product or is likely to buy the product. What do you think about this model? It's interesting, isn't it? Well, it's the same one that I showed you. For whether the person is going to be accepted to the university or not, but this time around is using money. I wanted to show you both examples before we go to recess. So let's take 10 minutes break before taking a look. The other ones are not required to go into that. Based on the plan, is only to show you that there are other ways to classify the data, are pretty much like logistics regression, but different ways to apply the models. So in other words, it's always suggested to use more than one model for classification to understand whether your data is accurate. But I don't want to overwhelm you with too many models. That's why I just wanted to show you there's a classification model like this one, which is binary, but there are other ways to classify the data. So let's take 10 minutes break and return by 21st minute after 8 o'clock. I think someone has a question. Yes, no worries, Rafael. Please go for it. I mean, first things first. And you can take a look to the recording later on. Because our deep model, I mean, you already understood the most complex part of this. The other models are only examples about what else you can do for classification, but you already got the most important part of the class.
Thank you.
Thanks to you. Have a wonderful evening. Okay, enjoy your recess. See you in 9 more minutes. Actually, 10. Okay, as promised. After 1 minute, 21 minutes over the top of the hour.
Recording in progress.
Okay, now, as I told you, these upcoming models are going to be an overview, right? And just to give you a good understanding about what else can be done in order to classify the data. So the first one will be the random forest. Okay, the random forest regression, actually decision tree and random forest. Okay. For the random forest, it's another way to classify the data. That means that you can classify the exact same data set. The only difference is that this one will be classified a little bit using a different way to shape the data or the different way to provide the thresholds for understanding the data, but pretty much that's exactly the same, right? For instance, here, we will use, again, the same model, the same data set, which will be the social network ads. So in here, again, we do the same. We take the data set, right, which is social networks, and we will take between column 3 and 5. That's it, right? Afterward, we will create the factors. If you remember, okay, now I need someone to explain the factors one more time. However, must not be neither Emmanuel, nor Roberto, nor Ana, nor Gerardo. Someone else. Please let me know if you want me to pick it up. Okay, I'm gonna pick it up. Guillermo Wild. Guillermo, can you please explain us the factoring feature? Okay, he must have not returned back. Ibera.
Yes.
Can you please explain us what we're in here? Sure.
Yeah, so the factors are the different categories that, well, it's displayed of the categories for the model.
There you go. There you go. Pretty much, we are taking the entire universe of data, and in order to classify them, we are identifying based on the transactions, how many of those actually came through, and which transactions did not come through, and did not come through as a purchase, right? There you go. Beautiful. Thank you so much. Very good answer. So afterward, here I need another volunteer. Let me ask. Actually, not volunteer. I'm gonna pick it up. Naim, what's going on here in the seated and the split? Naim, are you there? Maybe not. Okay, Ayrton, what now that you're the next one? So what's going on here when we take the seat and we are performing the split?
Yeah, so in the part of the seed, we are telling R to assign random values to start working on based on my data set. And
amazing.
What do you say?
Amazing.
Oh yeah. And in the part of the split, we are taking the 75% of the data set.
Okay. Wonderful. Beautiful. Thank you so much. So I appreciate it. Great comment. And Brenda, you were about Brenda. Now that you raised your hand, let me ask you this question. Is this correct?
Yes.
Do you think that is correct?
I think that it's correct.
Okay. Let me ask you a question. Here, the split ratio. Do you find anything particular here?
What I remember from the last class, it was a fraction. I don't know if we can put decimals, I guess.
Yes, actually, this is decimals. But thank you very much. And Fabian, you were about to say something.
Yes. Well, you recommended us to be at most 40% of the data.
Yes. So I anticipate that this one is wrong. Can anybody remind me? I'll pick someone else. Let's say Uriel. So what would happen if we take more than 40%? What's the term that may happen? Or the consequence that we may have? Uriel?
Yeah, I'm here. Sorry.
Sure. No worries. Do you remember what would happen or what was the term that we mentioned when we use more than 40% to perform the sample?
Yeah, it's like the false. I mean, is the other 60% of the total universe that we have?
Yes, but let me rephrase my question.
Yeah.
Do you remember why we take only 40% of the data for the training?
Only 4% of the data. No, I remember there is only 4 for every 10 that we have. I mean, but I don't remember if the specific data.
No worries. So let's thank you so much. Let me bring the opportunity to someone else. So I think we have 2 hands raised, even more. Wow, I love the participation. So I'll give the opportunity to someone who actually hasn't participated. Dora, why?
Because you force the model.
Exactly. In case it were more than 50%, we would be kind of forcing the model to behave in certain fashion, right? Can anybody remind me what's the name of that term of forcing the model to behave, forcing the model in the bad manner, of course, How do you call it, Sophia?
Overfitting.
There you go. Beautiful. Exactly. Exactly. We establish that for the training test, we use only 40% of the entire universe of data just to provide only an idea or to provide only what are the patterns that the model must use to detect it. In other words, those that are actually false is something good. Those that actually we have blue in the red, it's something good because it's a real prediction. It's a real prediction. That means that someone who actually expected not to purchase it did not purchase it or did purchase it. I mean, those are, it can be identified as mistakes. Nevertheless, what it means, it leads me to understand that each time that a new person is coming across, it's going to be evaluated equally, no matter what, right? However, of course, we can increase the accuracy of our model without risking the overfitting. So it's where actually we use the 40% only, but we need to work on the data cleanup, right? So that's the way that we can increase the accuracy. Stephanie, go for it.
I have a question because I don't remember if you mentioned it, but for the set seed, is it always 123 or does that can change? Or is like there a rule to like put a number on the parameters?
That's, yeah. The 1, 2, 3 is the instruction to say the seeded is numbers.
Okay.
Yeah.
So it can remain always 1, 2, 3.
Yeah, actually, okay. I may be wrong, but I have never used any other seeded when I'm taking the sample of the ORDI data set.
Okay.
But again, I may need to research it. I have never used it. It doesn't mean that cannot be applied, but this is so big and so wide that someone who actually tells you, I'm an expert 100% in machine learning, I automatically disregard that person and try to hire someone else because here you're always learning and it's impossible to know 100%. But good question.
Thank you.
My pleasure. Brenda, you have another question?
Yes, I have another question. If this is a numeric number, you can put a seed talking to letters?
No, because you may need to use other different algorithms to use letters or to use this kind of values. Because at the end of the day, here we are testing, we are transforming actually here, for instance, here. On despite we're creating categories, we are still using numbers. Why? Because at the end of the day, numbers are easier to process and easier to identify. So responding to your question, we always transform even the categorical values. Categorical values means, for instance, let me give you another, I think I have another good example. Let me see what they're in decision. No, actually, I only have social network. Let me open another data set just to give you an example. Let me use the superstore, for instance, here, right? Usually what you do in machine learning, you actually transform any string or any category actually into a combination into zeros and ones. Why? Let me tell you why. Because the code cannot read this. The code does not understand clear cut. It does not. So what it does, let me give you an example. For instance, filter. Here, well, I have too many people. Let me use another category which is not that wide. Maybe state. State would be better. Are only 53 states in the US, I think. 52? 52. Let me give an example. Here, you know what? Let's use South or West. So what it does, the algorithm, what it does, it turns everything into a binary mode. Binary mode, what it means, For instance, here we have only central, east, south, and west. So let's say what the algorithm does, it says, you know what, central will be 0, 0, 0, 1. Central, everything that is central, the algorithm will say, you know what, I won't use the word central. I will assign an alias that it's in numbers. Okay, let me give you another example. For instance, let's take east. In this case, the algorithm would say, you know what, east would be 0, 0, 1, 0. Not the other way around. Not. Do you remember that the other had a different category?
Yes.
So this one has 0, 0, 1, 0. The other one had 0, 0, 0, 1, right? So this is kind of a silly example, but this is the way the algorithm works. Okay. So this is binary, always translated into binary. So once that everything is in binary, the code can translate it to strings, can translate it to numbers, and so on and so forth. So what I'm trying to tell you here, okay, no matter what you choose here, either way the algorithm will translate either categories. For instance, I told you car, let's say south, right? South is equal to 0, 1, 0, 0. We said that central was equal to 0, 0, 1, right? Central was 0, 0, 0, 1, and so on and so forth, right? North would be, and I'm including the entire string just to show you the example. And west, well, let's include east also. West would be, in this case, 0, 1, 0, 0, right? And sorry, 1, 1, 0. And last but not least would be east. East would be perhaps 0, 0, 1, 1. So, in other words, can you identify that those sequence of zeros and ones are totally different?
Yes.
The order, right? Mm-hmm. The order is totally different. So what I'm trying to tell you here is that the machine cannot read this, cannot read central, but it performs a translation as a machine code just to let you know. So it's what we are doing in the categorical values. So for instance, here, right? What we are doing is that we are translating a human being language to a code language. That's why we perform the seed, because we are saying treat everything as numbers, no matter whether those are categories. So that's why, and that's exactly what we are doing here.
Okay. I'm sorry if my question was a little dumb, but
No, whoa. Please, first, in my class, you can ask whatever you want. There's no such thing as dumb question. Every single question is important.
Okay, thank you, Professor.
So please, anytime you have any question, please let me know. I mean, I'm the professor, so I'm evaluating that your question is important. And for me, that question that you made, it's so important because actually perhaps someone else did not dare to ask, and it's important to clarify.
Okay, thank you. Thank you very much.
My pleasure. Samuel, go for it. Samuel, are you there?
Yeah, sorry.
Nothing to sorry about.
It's just another question about this 1, 2, 3 in the seed. I think that this indicates the random sequence, right? And if we change the numbers, it's going to change the random sequence.
The random values. Yeah, because we're seeing here we are 3 positions, right? In the entire seed, right? Usually, unless you had a huge amount of data, I don't anticipate. Honestly, I have dealt with huge amount of data. Have never changed the seed to 1, 2, 3. I mean, to be honest with you, I usually use Python, not R. So there may be slightly differences, but usually, I mean, here you can manage. If we are talking about millions of records, right? Because this is 2 at 0, which would be 1 plus 2 at 1, which would be 2, and 2 at 3, 2, 2, 2, 2. Yeah, it's kind of almost a million records. So I don't anticipate using more yet. I mean, it's a very good question. You may, it may be required to seed more than, because you can seed perhaps one only, of course, but maybe you can seed 1, 2, 3, 4, which means it's going to increase the number of places that you're including to the binary code. This is what we're doing. Increasing the places, which means we have like around 24 million records or so. Yeah, but you can increase as many seeded as required, depending upon the amount of data. But yeah. However, honestly, have never gone through more than 1, 2, 3. But I mean, if it were the case, if you have more than categorical values or too many categorical values or too many records, of course, it's required to increase the seed in order to increase kind of the amount of categories that you can assign or the amount of sample data that you can get, sample random values that you can get out or your entire world. But you may, for instance, if you get an error in the seed because it lets you know that it exceeds, you may need to increase the number here in order to let it know that you are increasing the amount of random values between the last and the least value in your entire population.
Okay, thank you.
But very good question. Thank you very much. Okay, so now when we go to decision tree classification, the decision tree, what is it doing? Let's say, let me give you an example. Okay. So the most common decision tree that we know is there yes or no, correct? So imagine that we have this situation. Or maybe the male, female. Well, I'm sorry, that's a bad example. Nowadays, there are more genders. But let's say that it's based on, oh my God, nowadays everything's politically incorrect. Let me think on something that is not politically incorrect. Maybe, actually, I'm Googling, honestly. Let's say that we have just chromosomes, right? Just like that, chromosomes, without getting that into the different genders. My apologies, I'm an ignorant in that topic, so I prefer not to touch it. So if we are talking about chromosomes, either we have Y or X, or we have XX, right? That's it. So this is kind of decision tree. For instance, decision tree, do you identify yourself as a male? Then in that case, you'd go into XY, I'm sorry, it's XY or YX, I don't remember the order, but it's something like that. But if you identify as a female, it goes to XX, right? So, however, what if we included another level? What if we included another level? Do you consider yourself, let's say, older than 15 years old or younger than 15 years old, right? It could be a yes or no, right? So here, are you older than 15 years old? Yes. You are older than 15 years old? No. And so on and so forth. So as you can see, depending upon your situation or the situation of the business is whether it's a yes or no, or is likely to go to one way or the other. Now let's change it a little bit. What, instead of something binary like this, we use the percentages. Do you remember that I told you something obviously bigger than 50% is likely to happen, something less than 50% is less likely to happen, correct? That's exactly what's going on here. Let's imagine that the no, it's something less than, let me look for the freaking less than in my laptop because it's in a different language. Let me put it less than, just like that. Less than 50%, the expectation was to use the symbol, right? And here would be more than 50%. So in other words, based on the historical records, if something says that is XX, it's because it's more than 50%, and it's something that it's wrongly identified, well, is less than 50%, something. Crystal clear about how it works? The yes or no depends upon that factor that I told you. More than 50% is a yes, less than 50% is a no. That's it. Crystal clear. Straightforward. Questions so far? That's how the classification works in decision tree. So it takes the transaction, and afterward, actually we said decision tree. And afterward, it creates the categories, right? Whether that person purchased or not. So let's do that. We already had it. We performed the seed where actually we said, okay, it's going to take only 3 places or three places in a binary approach, which is going to be which are going to be integers. Again, take only 40% of the data to train it. Afterward, split it and split it to create the training set, which is going to take that 40%, and afterward take the remaining 60% to train our data. We're familiarized with this. Afterward, in this case, we're performing feature scaling. Can anybody remind me what does feature scaling stand for? Or what is that? Or what do we do this?
It's going to fit like the size.
Exactly.
Yep.
Perfect answer. And actually, you answered better than the way that I would have done it. Most probably, I would explain it more complex. So thank you for that. You explained it pretty well. Exactly. It's going to adapt whatever transaction we have to the size of the chart. We only perform the feature scaling. Well, actually, we can do it also for the prediction. Never mind. Why? Because this is going to translate something into, instead of being $1 million, it would say perhaps is based on all the data, I would say this is a 1, right? While a $900,000, it would say is a 8.9. It's just to scale it based on the size. So that's exactly what we're doing. And we are doing first for the training set and afterward for the test set. Okay. Now we are performing the classifier, where the classifier, if you can see, we are using a different method or a different method. As you can see, can you see the difference? The other one was LM. This one is called R part. And actually, the one that we used for logistics regression was GLM, right? So as you can see here, we are using a different method. But if you take a kind of a deeper attention to it, the shape is exactly the same. Why? Because it is classifying. At the end of the day, the only thing that you need to change pretty much is the method here. The remaining steps will be pretty much alike when you want to test different methods. Why? Because in nature, it's doing the same. Taking the data, understanding it, and classifying them depending upon the model, right? However, let's see the shape of the charts once that I run the random forest. Okay, let's do that. So let's run the random forest model. Okay, afterward, here what we are doing. Do you remember why pred is the dependent or independent variable? We are predicting the dependent or independent variable.
The dependent.
Dependent.
Perfect. Exactly. What we are doing here is that we are taking the test set. We are taking the class. The class is nothing but what we did here to create the different groups. This is the class, right? Which is is a factor. So it's gonna classify, it's taking this class and create the factors. So that's why it says class. So this is gonna take, what is gonna be? It's gonna be a placeholder. A placeholder is nothing, the class will be the placeholder to say this. Okay, I'll create the ypred. We'll create a new class, which would be either yes or no. So in other words, we'll classify or assign a class for your data depending upon whether it fulfills or not. If it were more than 5%, I'm sorry, the dot 5 would be a yes. If it were less than 5, then dot 5 would be a no, right? Do you remember that? Yes? No, if it were less than 5%, where should I put it? If it were less than dot 5, I'm sorry.
0?
Yeah, exactly. If it were more than dot 5?
1.
Beautiful. That's exactly the way that it is classifying the data based on the logic that I told you here in the decision tree, right? So that is exactly what it's doing. However, let's take a look to the predictions. Based on the predictions that we've made, how many of them are closer to reality? In other words, based on the test and the training, we'll compare similar values, and based on those, we'll say which ones were more accurate than others. So let's take a look. Guess what? So for the first one, it says, okay, for the first test, we said that it was about to be 0. It was 0, guess what? 154. For those that we said that were about to be 1 and were 0, guess what? Those are errors. But as you can see, the remaining ones did not happen. What it means, for those who detected that were about to be false and were true, nothing. Those that were detected to be 1 and were actually 1, nothing. So what it means, we have only an accuracy of, it's pretty much like, like 70%. So let's take a look. Actually, I didn't have the formula, but we can bring it over. So in order to include the accuracy, look at this. Well, would be all this. But anyways, let's not do it for this one, but you can do it. Just copy the code and apply it here, just for not wasting time. What I want to show you are the results into the chart. Because remember, these ones take a while to plot. Oh man, it's too big. My computer, what? I just ran it this morning. So let me release some memory. In order to be capable to run the thing. Let me take a look now. This is nothing but a RAM thing. Now it says what? How much more? Oh, this is shameful. Oh, still. It says 221. Oh my. Let me close maybe the presentations. This is unusual. Oh, the Zoom. The Zoom uses a lot of memory. Anyways, so were you able to run these charts by any chance? That you are using less memory than me? Has anyone run this?
Yeah, I tried, but it gave me an error saying that there are no package with the name LM state learn.
Oh, okay. Those were I think.
I find it blog, and it's necessary to install the package from the library on this here. And
oh, you know what? I think this is the Z. Do you remember that I showed? Oh, okay, I did not show you this. The Z. How are those called? Those are packages that you need to install from my local. Actually, that's something that it was my bad. Perhaps I should have told you before, because those were removed from the standard transaction. So it's called LM Start Learn. Maybe it's not installed in your local, but I will create a video to show you how to install that library because it's no longer public. So they changed just this year. So I created actually, I will need to create the explanation about how to install the element stack learn libraries. So it's something I need to show you. But I'll do it into the next class. Just let me release some memory so I can show you the charts, and I'll show you how to install that particular library. So let me see whether I now have some memory. Oh, it seems to be working now. But yeah, it requires to run another, first download the library in your local, and let me show you there, where. For instance, here. And afterward, I'll show you how to install it, but I'll give you the details. Some documents online. Let me see whether I have the instructions already. I totally forgot about it. I apologize for the same. But I'll share with you that code for not wasting any of your time. Yeah. Let me send you the instructions. I just included them tomorrow tops, so you can run the libraries. I'll share everything. I'll share the libraries that are required and also the way how you can install them locally. But the idea is that once that you install them, actually, though you must be able to see them into your chart. I'm running out of memory.
Yeah, Professor,
there you go.
I used the link that Ayrton sent us, and I was able to do it. Yep.
Oh, wonderful. Can you please share your screen, if you may?
Yep, sure.
Let me stop sharing so you can share your screen. I think it's going to release some memory from me and help me to show the charts. But please share your screen. It must look quite similar as the other, but the difference is that the data must be divided by squares rather than a line. So you can take control. Let me see whether I can give you control. Can you share, or it's giving you an error?
Just give me a second. I am not used to.
No worries.
You also share the image first.
You know what?
Open it.
Yeah, you opened it? Okay.
Yeah, that was not completed. Let me just send.
Yeah, because actually, let me share my screen. Yeah, let me take a look to my memory. But what is going to happen, as you can see here, we have dots, right? So these dots will be colored based on.
Sorry, Professor. I sent the good one.
Beautiful. There you go. This is the one. Okay, let me reshare my screen. So as you can see here, what actually I would request someone to give me an opinion about what difference do you find with the logistics regressions and this one. One volunteer.
I'll say that it's pretty similar, but it's 2 dimensions instead of 3.
And something else, do you remember that in the other one there was a single line across the entire data set?
Yeah.
However, actually, unfortunately, I removed it. But in the other one, it had a single line. This time around, it created 2 levels. As you can see, created a threshold here and a threshold here, rather than being a single line across the entire data. Why? Because it creates levels. It's a decision tree. So remember that it does, okay, are you above, are you, let's say, above 20 years old? Yes, okay. That means above 20 years old is going to be in the blue data set. Are you below 20 years old, for giving an example, it's going to be in the red data set. Afterward, it says, okay, based on your age, let me compare how much you are earning. So are you earning more than $30,000? The person says no. Okay, no, then you go to the below category, right? You earn more than $30,000? Yes, okay, you go to the blue category. Now, the training test would say, okay, those who actually are younger than 30 years old and earning less than $90,000, I'm going to evaluate all of them and see this one category purchased it? No. This person purchased it? No. This person purchased it? No. This person purchased it?
Yes.
Yes. Something that it's kind of unexpected, right? Because it's a young person earning a small amount of money. Guess what? That person actually bought it. But as you can see, the threshold is now including more people for those who actually bought it than those who actually did it. Why? Because it is using layers, different layers across the data in order to identify the decision tree based on those bias around the statistics, or that weight, better said, weight on statistics. So as you can see, it's much more powerful. So actually, if we do the same for random forest, let me see whether it runs based on, okay, let me invoke the directory. Here we go. The random forest thing. See it. Here we go. Take the data set. Let's do the same exercise. I mean, as you can see, the code here, we're creating the categories based on whether they're purchased it or not, one group and the other. Afterward, we actually, the training set is too wide, right? We said that at most it should be 40%. So that's my bias. That's my mistake. There you go. Afterward, we perform the scaling in order to adapt it to the chart. And let's see whether here, as you can see, we are creating the classifier. This time around, we are using random forest rather than using the other one. But as you can see, the shape, it's exactly the same. The only difference is that it will use a different data set. I'm sorry, it will use a different model to apply it. We create a prediction here. We don't need the confusion matrix. That's only for Showkins. Hopefully it runs. I'm not running out of memory, hopefully. And seems to be running. There you go. Wow, I think I released some memory, and that is gonna help us to plot it. And let's see the difference. As you can see, it will have some slightly difference. In other words, it would create different layers to classify the data to actually identify, avoid, as you can see here, right, like this, right? Random forest. What it means that it creates different layers out of the data. And now in the previous one, which is the decision tree, we had something like this, right? This corner here, and afterward, everything here was blue and everything here was red. Now let's take a look how it looks like, which means this is going to identify more outliers. It will identify more layers to let you know, guess what? This guy, which actually is older and he earns more than a $20,000, guess what? I anticipate that that person won't buy it. Why? Because he's more biased to the .5 rather than being above and beyond. As you can see, it's pretty much alike as the other. Let me bring the image. The only difference is that identify some outliers that are important to take into account that gives you more certainty about the predictions. So, is there any question so far? As you can see, the three models provide you similar information. The only difference is that the combination of them will let you know how accurate your prediction is if all of them are closer or higher than 85%, or let's say 75%. So use a combination of them in order to perform your predictions and understand the accuracy, and that would give you kind of a better outlook whether your transactions are being classified in the best fashion as possible or not. Questions before we close it out for the day? Comments? Suggestions? Complaints? Jokes?
No? Professor, quick question. Did you already share all those codes? I do not find the random forest.
Random forest is not there. Oh, might have been my bad.
The decision tree.
I think I shared all of them, but I may be wrong. Let me take a look. Linear regression, decision tree. Okay, random forest is missing. You are totally right. Let me include it here. So, thank you so much for bringing that to my attention. So,
thank you.
No, thanks to you. Is there any other questions so far? Comments, suggestions?
More than a question. So go ahead, Gerardo. Sorry.
Thank you. The way to compare the different models, for example, random forest and the decision tree classification is only comparing the accuracy calculated by the code. And
That's
you
a
can
very
select.
good. Yes, yes. Actually, my suggestion is, well, I mean, it's a more advanced situation, right? First, you perform a logistics regression. You can export that outcome of the data. Once that you export that outcome of the data, you perform the next model, which would be decision tree regression classification. Afterward, you perform a random forest, and as you use the remaining set of data that has been kind of cleaned up and classified, it will increase the accuracy of the model. You can either compare which one has a higher accuracy. Why? Because each set of data will work differently depending upon whether it has outliers or not. If you have outliers, random forest would work better. If you don't have outliers, then decision tree would work better. Does it make sense? So depending upon the nature of the data, it's which one will be more accurate. My suggestion is you need to classify data, use them all, and the one that has the highest accuracy, use that one. As long as it is closer to 100%, of course. If it's too far away, I suggest you to use one first, export the data, the outcome. Use the second one, export the data, and use the last one in order to ensure that the accuracy increases over. But that is something that it's an advanced skill that you'll develop over the time. It took me 10 years to develop that skill, honestly. Does it answer your question?
Yes, thank you.
My pleasure. Is there any other questions so far before we close it out for the day? If there are further questions, thank you so much, everybody. Hopefully you find kind of more value about the algorithms that we're using and also more applications to the algorithm in order to make sure that you feel comfortable about what you are doing and also that you find sometimes application to that particular model. So I think those are powerful, are helpful to take decisions, will help you to understand your data and classify it or visualize how it's going to behave and help you the main focus to help you to take decisions. Thank you so much, everybody. Have a wonderful evening. See you on Thursday.